skip 7. Let's do one of these where we actually solve, like maybe 8, 9, or 10. 8's a pretty simple one. Maybe look at 9. The goal on those is to actually solve for x. In 9, you've got this 5 to the x times natural log of 5 equals twice to the x. Now, if I was looking at this problem, that piece right there makes it kind of funny to me. Does it make it kind of funny to you? Is it a number? It's just a number, right? So don't be too concerned about it. It's just a number. Oh, it is. It's just a number. If it said 5 to the x equals 2 to the x, if this was the case, how would you solve that?
If the basis equals what you can equal.
Yeah, that's what they teach you when the numbers are nice. Like if that was an 8 on the left instead of 5, that's what you did. But it's not. There's no nice power of 2 that generates a 5. I know your algebra 2 teacher taught you this, and I know that you taught that you're learning some doing homework. You're well on both sides. You take the natural log of 5 to the x and say it's equal to the natural log of 2 to the x. And you get your x's up front. That actually means in this one it didn't, because that doesn't make any sense on this problem. But it would give me something on the other one, because I actually think I'd be able to do an isolation maybe. If I do the same thing, 5x natural log 5 equals 2x. And I can natural log both sides of this thing. I'm going around the world on this one. My second bad teacher moment of the day. What was a third? No, I don't like what I'm trying to do here. I don't like it because this would be what I'm trying to do. You can't carry that x out front. So apparently I'm having a bit of a brain fart. So what is the best way to attack this little problem? The natural log is going to be involved in it somehow. Riley, your idea was good if we get the exponents to match, or the bases to match. That's what the whole point of the natural logging of both sides is. It's a quick conversion technique. You guys got any suggestions? Something I'm missing? There's 7 of y'all and 1 of me. Oh, so no suggestions? You're gonna have to fall back on a rule. That's what you gotta fall back on. So I went the wrong route with that sucker. It's just not gonna do it. Sometimes I like things too. Like the natural log of the natural log of 5. Like my gut says that ought to be something special. It's a crazy decimal. I wonder what kind of crazy decimal it is. Not that guy. Yeah, couldn't shrink it down that far. So I've gotten off somewhere on that one. Trevor, you got any ideas? No, nothing? There it is. It was, wasn't it? It took me a minute too. But that's going to give me something that I can work with. Look kind of ugly. Actually, it looks really ugly. But, and it's not quite there. It's really not quite there. But this log base E of 5 is just a number, right? That's just a number. So some number equals 2/5 to the x power. That's something we can work with. It really is. It is something we can work with. Probably could have left it as a natural log, but let's see here. If we did log as bay, we'd have something that looks really funny. E to the 2/5 to the x equals 5. Yeah, I don't know if I can do anything with that. So where else can I get with this thing? See, I may have just gotten myself to a point where I still don't know what to do. I think I still want to do what I was trying to do before. I do think that. Let's see what happens if I ln both sides. This was a natural log of 5. My natural log of natural log of 5, and say it equals x natural logs of 2/5. I can isolate that x, can't I? I wasn't in a position to do that earlier. Earlier I could not isolate that x value. That was the problem, because they both had an x on the left and right. So it looks really funky, but the natural log of the natural log of 5 divided by the natural log of 2/5 is my answer. So it's kind of a funky little problem. That took a lot longer than I anticipated it taking. I've been doing this stuff a long time. I mean, sometimes you just got to think. I do remember being your age and staring at problems for 20 or 30 minutes before I figured them out. Did any of y'all ever just stare at them for a long time? I mean, that's how it is. And, you know, a lot of kids around 4th or 5th grade, they quit trying to figure it out. That's the difference between y'all and them. They used to spend time trying to figure things out. And they just quit doing it. It wasn't that anybody was really that much different than anybody else. They just quit trying to figure it out. You know, if it didn't come to them in 5 minutes because of their temperament, they gave up. So y'all have a much better temperament about this kind of stuff. You don't quit. All right, number 10 is way easier than that one. Way easier. It won't be a problem because of the way it gets set up after you take the natural log on both sides. If you ln both sides on this one, I'm not going to show the step. That x plus 1 would come out front. You have x plus 1 natural logs of 3 equals x natural logs of 2. What you can do is you can invoke the old distributive property right now. X natural logs of 3 plus the natural log of 3 is x natural logs of 2. I'll let you brainstorm on that for a second. It's actually kind of like when you've done implicit differentiation and other things. If you want to solve for something, you get it where? Too early for that step. You're solving, if there's just x's in an equation and you're solving for those x's, what do you do with them? You put them on one side. You just go back to when we first started teaching algebra, in 7th grade, 8th grade. There's an x natural logs of 3. You're going to take away an x natural logs of 2. And on the right side, you're going to have a negative natural log of 3. Now, the only real difference between this and when we were young is factoring and, funky looking numbers. Like if anybody would have told you ln of 3 is a number in 7th grade, you'd be like, what? That's not a number. What is that? Right? That's the only real difference, though. What can you pull from both terms on the left? Pull your x. You got your natural log of 3, take away your natural log of 2. That's still equal to your negative natural log of 3. And then your isolation step. Simple division. Once upon a time, I was going to have the school buses get stickered out with all the formulas we use in high school. For some reason, I just never got around to it. I permission from central office, the bus garage, but I just never did it. I don't know if it would have done any good or not. But I figure if the kids stayed with the quadratic formula from kindergarten until 8th grade, by the time they got to 9th grade, they'd be like, oh, you guys remember y equals mx plus b? Where'd you first see it? Gas station.
Oh,
That was the first time you ever saw it.
that's true.
Probably why you remember it so well. The groups that I'm starting to get here recently, they don't remember it. That old gas station uptown, it's where WK&T is now. You guys saw that for the first 14 years of your life.
No, it wasn't that.
A couple of years ago, I mean, as soon as I'd mention y equals mx plus b, they'd be like, "You mean like the gas station?"
I remember.
Everybody
I
remembered
would
it.
have never found it. But I saw it for years. I remember seeing it.
It's probably why most kids, up till a couple recently,
Is it
are painted over it. It's kind of sad. That was painted up when I was a kid by students who had Miss Buckley. That's where it goes way back then. All right, on to funny looking derivatives. So if u is a differentiable function of x, then the derivative with respect to x of some e to the u, which is just a function, might be like e to the 3x. But the derivative of e to the u is the one that people joke around like, you're so dumb you don't even know the derivative of e. The derivative of e to the u is e to the u du dx. It's itself times the derivative of u with respect to x. I can prove this to you. Should you care to be proven? You can go with trust. You don't want to see the proof? All right. So the derivative with respect to x of e with an argument is simply e to that argument with the derivative of that argument. Nothing more. All right. If it was a 3, it'd be 0, because that's a number. Just remember little things like that. All right, so you don't want to see it. I guess we need to do an example of it. Find the derivative of y if y is e raised to the x cubed power. All you got to do is know your derivative rule. All right, get done again. I'm going to write du. So our y prime or dy dx, whatever you like here, is e to the x cubed. And what do I have to take the derivative of? The x cubed part, remember. Now, some kids need to write things off to the side, like, okay, if I look at my formula, u is x cubed, I know I gotta have du. And du is 3x squared. Some kids don't. I think it gets a little tedious. There are times when I wish when I was instructing I would put it in there. I usually don't realize it until it's too late. There's your derivative. Just make it look a little better. Personally, I would put the 3x squared first. Just looks better that way to me. And most people who teach this, that's how they do it. Any glaring issues with that? No, it's pretty simple. You guys can probably do this one without really showing any work. What is the derivative of e raised to the x plus x squared? Anybody? That's in there somewhere. Are you going to put it up front? 1 plus 2x? Good with that. Anybody got any issues with it? Trying to think if the author of the book would do anything different with this. Sometimes they leave them factored, and sometimes they don't. I wouldn't be surprised if you saw something like this. E to the x plus x squared plus 2x e to the x plus x squared. You know where that came from? How did I come up with that answer? I distributed it. You know, don't be surprised if you see stuff like that. Sometimes they're real dicks. Little things like this can be rewritten. Don't be too shocked if you see little things like this. If it's e to the x plus x squared, that's e to the x times e to the x squared. You remember why? Yeah, when you multiply together, you have exponents. Don't be surprised if answers look a little funny when you check them. Somebody has decided this one can look prettier if we do a whole lot of complicated steps and try to make it look nice. But I think as it is, this is about as pretty as it's going to be. The first one we have. That's my opinion, though. Yeah, opinions are like buttholes. All right, here's the derivative of some a to the u. A to the u is something like 2 to the 4x, okay? That's all it is. Here, a to the u is a to the u, natural log of a, and then the derivative of u with respect to x. I have no desire to prove that one to you, so if you are curious, you can look on page 173. And our only example in here is about writing, no, it's not even about writing an equation. It says at what point on the graph of the function y equals 2 to the t minus 3 does the tangent line have a slope of 21? Okay. Well, since it's talking about slope, what are you going to do? You're going to take the derivative. And you're going to take the derivative, and you're actually going to set it equal to 1. That's what you're going to do. So your first step would be to find your y prime. Here's a 2 to the t. Does 2 to the t look like e to the u? It does. Think about 2 to the t and a to the u and how they line up. I know that a is 2, and u is what? T. I follow my little formula. Oh, if you ever look in your book, part of me thinks about teaching things like this. I don't know if you ever look at your book for help. But what they would do is they would show all the steps and say, okay, we're going to take the derivative of, this is actually the derivative with respect to t, not x. We're going to take the derivative with respect to t of y, and we're going to take the derivative with respect to t of the left, 2t minus 3. They show all of those steps like that, so don't be confused if you look at your book for help.
Now, the derivative with respect to t of y is just going to be dy dt. Now we've got to do that derivative with respect to t of 2t. So I'm just going to plug into this thing up here. Still got a to the u, it's 2 to the t. Natural log of a, and what was a? 2. Times the derivative of t, in this case with respect to t. How many can we take the derivative of x with respect to itself? It's just 1. And what's the derivative of your negative 3? 0. It's constant. So there's our equation. And we're going to replace that dy dt with what? 21. 21 equals 2 to the t, natural logs of 2. So you still do have to do some of that algebra 2 stuff. You do still have to do some logarithm solving and exponential equations. We're going to isolate 2 to the t. We're going to isolate the base for the next exponent. Because if we isolate the base for the next exponent, we can convert it to a logarithm. Or we can just add in those sides. There's lots of techniques we can do. I'm not going to go to my calculator because that would just make this some really ugly decimal. If you want to go to your calculator and start writing down long decimals, you go right ahead. I'm not going to. Left-hand side is just a number, and that's equal to a base for the next one. That's all it is. You already took your notes yesterday on how you convert a situation like that. Or we can do the LN technique. What do you want to do? You want to LN both sides, or do you want to convert to logarithm? Worry about converting to a logarithm. That would be a logarithm whose base is 21 over the natural log of 3. I would LN both sides. It makes it kind of ugly to just go the LN both sides statement. I didn't say we couldn't do it. You'll get the same answer either way. I'm going to LN both sides. So natural log of the left would have to equal the natural log of the right. And where does that t go when the natural log is right hand side? Up front. Then we can do our isolation. So we do your isolation. There's your t. In its pretty beautiful form.
That's not the entire answer to the question, though, is it? No, that's part of it. They wanted a point. You found the x value, is what you found, because you found the independent variable t. And now you got to find the y variable. It doesn't mention anything about writing this in exact form. We'll just see what happens when we plug it in exact form. Sometimes things work out pretty nice. All right, so I've got the natural log of 21 divided by the natural log of 2. Close, close. Turn around and divide it by the natural log of 2. Ugly looking decimal. I'll store it to x. That way I can just type in this equation right here. So 2 to the x minus 3. Yeah, it still didn't work out nice, did it? So we got about 4.92 and about 27.30.
Be hesitant on rounding. You know, they teach significant figures in chemistry for a reason. Be very hesitant on rounding. That's why I don't round until I'm done.
Our next big leap is a society would probably become a spacefaring society. You're not going to do a whole lot of rounding and stuff like that. Rounding's okay when you're building a house. It starts becoming pretty restrictive when you build a very tall skyscraper. But when you talk about the next level of engineering, you really do not round. So be hesitant on rounding. All right, what do we got here? The derivative of the natural log of something. It's almost as easy as the other one.
Derivative of the natural log of something, in this case u, is 1 over u. And guess what else? Du. Du dx. You guys don't want to see it, do you? No?
You're just not curious?
Okay.
Well, that saves time, I guess. All right, so find dy dx if y is the natural log of 3x squared. It's a pretty simple deal. Just think of your rule. It'd be 1 over 3x squared, and what else do you have to do?
Derivative of 3x squared. 1 over 3x squared. What is the derivative of 3x squared? 6x. And simplify, obviously. Don't you leave an answer like that. 6 over 3 is what? 2. You got an x over an x squared. What's left unknown? X. Now, if you want, we can do a whole lot more explaining on that. Elizabeth, do you need any more explanation?
No.
Okay. Anybody need any more explanation? Moving on then. If u is a differentiable function of x and u is greater than 0, the derivative with respect to x of some logarithm with a base and an argument u is 1 over u natural logs of a u. The whole.
There was a funny one in here somewhere. I was thinking about integration. I could have swore there was one that was really funny looking. But I'm probably thinking about integration.
Do you care to see how? Really? Yes? You felt bad? You don't.
Just,
Okay. So log base a dx is the natural log of x over the natural log of a. Any issues with that? No. Okay. Well, what we'll do is we'll take the derivative of the natural log of x over the natural log of a. How do you take the derivative of something like that? Use a quotient rule. What do you use a quotient rule? Do the natural log of a times the derivative of the natural log of x. What's the derivative of the natural log of x? In your notes, except you have a u there. 1 over u. So this derivative of the natural log of x is just 1 over x in this sense. And the derivative of the x would be the number 1. I have 1 over x. What's next in the quotient rule? That's the fraction sign. I looked at it before I asked you a question. Plus 1 over minus 1 over a times the natural log of x. The bottom is natural log of a squared. So believe it or not, that will clean up to that. Somehow, some way, they're gonna clean up to that. Probably not done very quickly. I'm wondering if there's a shortcut. It might take me a long enough. I've derived this in about 2 years. Last year's group, you can try to see it. The year before that was a very inquisitive group. Yeah, there's another shortcut in this one. What we're gonna have to do is we're going to have to shift some stuff around. This X and that A, we can, actually, they can't move that. We need to put these fractions together. That needs some help. So I'm going to give this 1 over A ln x an x, because there's a fraction in there. I'm going to give this front piece a natural logs of A. The 1 over x is going to cancel itself out. Or sorry, it's still there. Sitting over xa minus, this one gets the x natural logs of x, sitting over xa. Is all actually sitting over 2 natural logs of a. Because I can take that 2 and move it up front.
Now what can we do? What can we do with that XA? Can you shift it down low? You can shift it down low.
I can see the next step, but I can't see it today. It's close to what it needs to be. Maybe that 80 disappeared, I don't know. A natural logs of A is the natural log of A to the A. You guys get that?
Seems like there's a shortcut there. Natural log of 2. I could be imagining something to the second. Is that? That may not be what I wanted it to be. So Riley, I think you asked me the one that I'm not entirely sure about. I forgot something. Is teacher moment 3? Sure, there's usually a third one. What did I forget or what did I screw up? Let's see what the Brits know that I forgot. Before I had kids, I would actually, go over my content every day and rememorize it. Now I just show up You know, I thought about that from the beginning. I didn't do it. You ever feel stupid?
I have these moments every once in a while. Every day, actually. Let's see, it's sort of like 1 over Oma. That's a number. That's a constant. Makes all the difference in the world. Really does. So how you might view this function is that it's 1 over the natural log of a times the natural log of x. Remember, this is a number. For all intents and purposes, it might just be 3. So we don't even have to worry about this thing's really, do we? Nope. It's 1 over ln a, the derivative of natural log of x, which is x, and then dx, whatever's left, which is exactly what the problem is.
Is that not what it is? Yeah, when I was going around the world with it. We would have gotten there somehow, but it was beyond me. Probably just need to realize that those ln of a's, those derivatives were 0, and we would have been there. Would have had it. Sorry. All right, find dy dx if y is log base a of a raised to the sine of x. Now this is actually a really easy problem, but we're going to do it the long way, and then I'll show you the short way. So we're going to do it the long way. Long way means you have to use a chain rule. It's in there.
Now, when I first look at the setup here, I have a log base a of u, right? Kind of what this is. This is log base a of u. Where u is a raised to the sine of x. So I'm going to go with it. I'm just going to follow my setup. dy dx. That was log base a of a. That's what we just did, right? We're going to roll it. Okay. So 1 over u, which is a sine of x, raised to the sine of x, natural log of a to the sine of x. No. Just that. LNF times du. That's the next part, times du, right? There's a reason I didn't show it here. We're going to have to come off the side here. We're going to have to figure out the derivative. All right, so we're kind of doing this again. Here we have an a to the u equals a to the sine of x. We've got to take that thing's derivative. We do. How do you take the derivative of a to the u? A to the u, natural log of a, du. There's a lot going on in this problem, because I get that. There is. That's how you take the derivative of a to the u. No, it's not. All right, so this little piece right here, once you take its derivative, The derivative with respect to x and sine of x is a sines of x, natural logs of a, and then I got to take the derivative of sine. Cosine. I'm supposed to be able to sine x.
Is it cosine the x and exponent?
No. It's not. Just like the easier ones, it's just down on the same level. So dy dx is 1 over a sines of x, natural logs of a. I get to multiply it by this thing right here. Multiplication happens up top. Sometimes it makes sense to throw it up there. A sines of x, natural logs of a, cosine x. The reason I wrote it like that was so that the simplification here would be easier. You could throw away a whole bunch of stuff, don't you? Yeah, all cosine is all that's left. I didn't do this the long way to confuse you. I'm sure that happened. Sadly, not everything has shortcuts, but some things do, and it pays to see them. It really does pay to see them.
So would you like to see the shortcut? This calculator is new enough. Yeah, it's got log base. Log base 2 of 2 is 1. So log base a of a is 1. That's your shortcut. The reason I did this a long way was to remind you that when you look at things,
Think about manipulating them first. So the shortcut here, not all problems have this, is to rewrite it at first as sine of x log base a of a, and then realize that that piece is 1. That's saying what power of a generates an a. So y is the sine of x. And then it's easy to find dy dx. You just memorize the rule and get cosine. Way easier, right? But some of the stuff you do in your homework is going to be fairly complex. You're going to have that chain rule in there.
so that's kind of why I did that one the long way. And it is a pain in the butt. You've got to come off the side and say, oh, this guy. Well, this guy's got something else going on with it. I think we took 3 different derivatives, didn't we? For one problem? It happens. All right, find y prime if y is equal to x to the raised. This is a more typical problem. If y is x raised to the cosine of x.
Well, when you see something, when you see this one, you ought to be thinking about a to the u. This is a to the u. That's what it is. Any issues with that? That is a to the u. What is the derivative with respect to x of a to the u? Du. There is a little bit of a chain rule involved in this one, because you're also going to take the derivative of cosine, right?
I think our problem's a little different. We
Is
just
it?
have y equals x to the x, and then we have something that's just like, this is not a u, because a u or just.
You don't have y equals cosine of x?
Never mind.
No, I know x to the x is in there.
I don't know how I skipped that.
It happens. I don't know why I did so many stupid mistakes there, but that happened too. Oh man. I really don't want to teach this again tomorrow. You only have what, 2 examples left? Give it a shot. Either way, I'm gonna spend half an hour going over homework whether I do this or not. Just give it a shot. We all know that's true. Either way, we'll spend a half an hour going over this homework. Doesn't matter if I finish the lesson or not and give you 30 minutes class time. Just give it a shot.